Okay, so let's start with data cleaning now. Now, you see, why do we start first? As you can see the code, it's dfbookings.describe. Now that we have explored and understood the data set, so this data cleaning part, I'm starting with describe because this kind of gives me a statistical health check of all numerical columns. At this stage, I'm specifically looking for values that violate business logic or appear statistically unusual. And immediately one value stands out. The minimum number of guests, that is minus 17, as you can see here. I think which we have also discussed in our data exploration part. So hotel booking cannot have a negative number of guests. So this clearly is a data quality issue that needs investigation. Okay, so let's now find invalid guest. So we type the code df bookings list. This bracket, square bracket, is called list. Df booking again dot no guest less than equal to 0. Now instead of immediately deleting these records, I first want to see exactly which row contains the problem. So I'm applying a Boolean figure. Now if you see df booking dot no guest less than equal to 0 checks every row and asks, is the number of guests less than or equal to 0? So this produces true or false for every record. So by placing that condition inside df booking, pandas returns only the rows where the condition is true. And now we can clearly see booking containing values such as -3, -10, -12, and even -17, right? So in the no guess, as you can see, we have got all the negative values because we have, made this no guess less than equal to 0. So we have got all the negative value. Now, you see, data cleaning isn't just finding strange numbers. We are checking whether the data makes sense in the real business world. So now we will remove the invalid guest records. Again, we'll use df booking data frames for booking equals to df booking list df bookings dot no guest is greater than 0. So here, now that I've confirmed that these records are invalid, I reverse the condition. This time I am keeping records when no guest is greater than 0. So assign the filter result back to df bookings, which means our working data frame now contains only valid guest counts. Then we do df bookings.shape, where we get around 1,34,578 rows and 12 columns. So why I use shape? Because I want a validation check. Originally we had around 1,34,590 rows, right? If you see here above. See, 1,34,590 rows. But now, how much we have? 1,34,578. So yeah, you see the difference. There's like almost a difference of, you can say, 12 rows. Okay. So exactly 12 invalid records were removed, while all 12 columns remain unchanged. So this is like an important habit in data cleaning. After modifying the dataset, always validate what changed. So we validate that with shape. Okay. So now second, let's focus on investigating revenue outliers. For that, we use a code dfbooking.revenue generated.min parenthesis. Now, and also max in the same time. So minimum revenue generated is 6,500 and maximum, as you can see, is the number is too big. Even maybe it's like 28 crores or something like that, which is kind of looking at the orders and everything, I think it's not possible. So the maximum is dramatically larger than the rest of the values we have seen. But an unusually large value isn't automatically wrong, right? Instead of deleting it, we need statistical evidence that it may be an outlier. So you see, an extreme value is not automatically an error, it needs investigation. So what we do the mean versus median, revenue generated mean and revenue generated median, and we get mean is 15,378 and median is 13,500. Now, before defining an outlier threshold, I'm comparing the mean and median. Now, this mean is arithmetic average of all revenues. The median is the middle value after arranging the observation in order. Here, the mean is approximately 15,378, while the median is 13,500. So it means that the mean being higher than the median suggests that some large revenue values may be pulling the average upward. That gives us another reason to investigate the upper end of the distribution. Then we move on to mean and standard deviation. So as you can see, we use the formula, we use the code average, comma std is equal to df bookings dot revenue generated dot mean parenthesis comma df bookings dot revenue generated dot std parenthesis. Now you see I'm storing two statistics. Average contains the mean revenue and std contains the standard deviation. So standard deviation tells us roughly how spread out values are around the mean. So why do I need this? Because instead of declining manually that a revenue value looks so too high, I want to create a statistical boundary for identifying unusually extreme observation. So standard definition deviation rule is higher limit is equal to average plus 3 into STD. And for that we get the output, that is 29 to like it's like 2,94,498. So here I'm defining the upper threshold, okay? This is like, mean plus 3 into standard deviation is kind of known as a 3 standard deviation rule. In simple terms, I'm saying if a revenue value is extremely far above what is typical in this data set, flag it for investigation. Our calculated upper limit is approximately 2,94,499. Then what we do is we use the code and we find the lower limit, that is average minus 3 into STD, that is minus 263 minus 2,63,742. So we can calculate similarly a lower boundary using mean minus 3 into standard deviation. Here that produces a negative value, but revenue generated should normally be negative in the data set, so business logic still matters alongside statistics. So you see, statistical rules don't really replace business understanding. And before handling the upper outliers, I also check whether any revenue values are 0 or negative. So as you can see, the result is empty. There's no result at all. And so unlike no guess, we don't have a business rule violation at the lower end of revenue generated. So moving on, finding revenue above the threshold. Now, you see the formula DF bookings, then list DF bookings dot revenue generated greater than higher limit. Okay. Now I apply a calculated upper limit. I'm asking Pandas to return every booking where revenue generated is greater than approximately 2,94,499. This gives us a record that have been statistically flagged as extreme. Again, notice the workflow. Detect, inspect, and decide. I don't want to blindly remove data simply because the number is large, right? Then we will, okay, then we'll see how we'll remove the revenue generated outliers. So we'll do the code DF bookings, again DF bookings, then list DF bookings dot revenue generated is less than equal to higher limit, and then DF bookings dot shape. So result is, as you can see, 1,34,573 and 12 1,34,570 rows and 12 columns. So after confirming these extreme observation, I retain only records at or below our upper threshold. I then check shape again. The data set moves from 1,34,578 to 1,34,573. So only 5 records were removed. This is another reason why validation is important. We can clearly quantify the impact of every cleaning decision. So now let's investigate the revenue realized. Again, we'll use the formula. DA bookings.revenue realized.describe. So this is like the same statistical method which I used on revenue generated. Remember, revenue generated represents the booking value, whereas revenue realized represents the amount the hotel ultimately earns after considering outcomes such as cancellations and refunds. Using describe parenthesis, I can see distribution ranges from 2,600 to around, you can say, 45,220, right? So like the lowest is 2,600, 45,220 is the highest. So moving on, like there's like initial outlier threshold. So we use the code high limit is equal to df bookings dot revenue realized dot mean plus 3 into df bookings dot revenue realized dot std high limit again. So the output here we have got is 33,479. Now here we have used the same 3 standard deviation approach across the entire column, which gives us an upper threshold of approximately 33,479 rupees. So when I filtered values above this limit, Pandas return 1,299 records. At first glance, we might think we have found like 1,299 outliers, but this is exactly where business context becomes more important than blindly following a statistical formula. This is probably the strongest teaching moment here. Okay. Now, why these aren't necessary outliers? So you may think why these number which we have got is not current, like not specifically outlier. So looking at the output, these records are predominantly RT4. Okay. So looking at the records, we can see they are like predominantly RT4 only, 34,580. And when I inspect these supposedly abnormal records, I notice something very important. So they belong to RT4, our highest room category. A premium or presidential room naturally generates more revenue than lower room categories. So comparing RT4 revenue against an overall threshold calculated across every room category isn't necessarily a fair comparison. We are comparing different types of products with different pricing structures. So it's like comparing the price of luxury suit with a standard room and calling the suit price an error simply because it's higher. Let's analyze RT4 separately. Again, we use the formula dbookings.room category double equals to RT4.revenue realized.describe. So to make the comparison meaningful, I isolate the RT4 booking first. The condition room category is double equals to RT4 selects only those records and then I run describe specifically on their realized revenue. Now we are comparing premium rooms with other premium rooms rather than with the entire hotel inventory. So now we recalculate the threshold for RT4. The RT4 statistics show approximately mean is 23,439, standard deviation is 9,048, and maximum output is around 45,220. So we would just add it. So for RT4 specifically, the mean is approximately 20,439 and standard deviation is approximately 9,048. So applying the same three standard deviation rule gives us an upper threshold of approximately 50,583, but the maximum actual RT4 revenue is only 45,220. So it's far below the threshold. That tells us that these high revenue values are reasonable for this room category. Therefore, I don't remove them. So, what lesson did we learn here? Contexts can completely change whether values should be considered an outlier. So, moving on to the next code, that is DF booking. DF booking dot booking ID is equal to May 01 011 6558 RT213. Now here I'm demonstrating how we can investigate an individual booking using its unique booking ID. Now the equal operator, as you can see, double equal operator, checks for an exact match and Pandas returns the corresponding record. So this type of filtering becomes useful when investigating a specific transaction, anomaly, or business issue. So let's check the missing issue here. So we again write a code to check the missing values, that is dbookings.isnull.sum parenthesis. So another essential part of data cleaning is checking for missing values. Here I'm combining two functions. The sum, like first, isnull is parenthesis checks every cell and marks whether the value is missing. And the sum counts those missing values column by column. So what isnull does? It checks every cell and marks whether the value is missing, while sum counts those missing values column by column. The result shows that almost every field is complete, but ratings given contains 77,897 missing values. So as you can see, data frame 2 is null to true or false to sum is missing count per column, right? Now why we should not fill the missing ratings? Now we have to make an analytical decision. We could technically replace missing ratings with the mean or median, but that would create ratings that customers never actually gave. A missing rating may simply mean that a guest choose not to provide feedback. If I replace thousands of missing ratings with an artificial average, I would distort the actual customer feedback distribution. And because such a large proportion of dataset has no rating, deleting all these rows would also remove a huge amount of otherwise useful booking data. So in this case, the appropriate decision is to retain the missing ratings as missing. Now, as you can see in this video, we have identified a lot of things, and yeah, it's like now this next video is all about exercises which we have here. Uh, yeah, we can do that exercises maybe in the next video, because here, uh, or should we do it here? That's the main thing. If you want, we can do it here itself. I think we can do it here. Let's write the code and let's understand the problem statement since it's a part of data cleaning. Okay. So first one is in aggregate bookings, find columns that have null values. Fill these null values with whatever you think is appropriate. Substitute, like possible ways is to use mean or median. Now I think we have already returned such a formula, which is here, right? I think this formula can work here. So I'll do C, command V, and here instead of just bookings, I'll write aggregate bookings. And we would get exactly what we need. So as you can see in aggregate booking, find columns that have null values. So find these null values with whatever you think is appropriate substitute. Possible ways is to use mean or median, and that's how we get the null values for the columns. Okay, by using df aggregate booking dot is null parenthesis dot sum. So as you can see, is null checks every cell for missing data, while sum counts those missing values column by column. This immediately tells us where the data quality problem exists. So if as in the data set, the missing values are in capacity, let's first inspect them. So what we do is, again, we'll write a code where we'll use the like df aggregated bookings, then list, then again the bookings dot capacity dot is null, and then check the typical capacity values. So for this particular data set, the expected solution is typically to replace the missing capacity values with the median capacity. So that's why we use df aggregate booking dot capacity dot fillna bracket df aggregate bookings dot capacity dot median in place is equal to true. So yeah, moving on to exercise number 2. In aggregate bookings, find out the records that have successful booking value greater than the capacity, filter those records. So now we are checking something different. This isn't necessarily a missing value problem, it's a business rule problem. A hotel cannot successfully book more rooms than it actually has available. So we can use a formula successful bookings is greater than capacity. So first what we'll do again is we will copy, we will paste here, we'll put a list, inside that list we'll again paste df aggregated bookings, then we'll use the successful bookings column, and we'll do greater than, again we will dot capacity. And what we would do again is close the bracket. Okay. And there we go. So you see, if a property has a capacity of 30 rooms, for example, but the data set says 35 unsuccessful booking, the record violates the expected business constraint. Once you have inspected and confirmed those records are invalid, keep only valid records. And again, how we'll validate it is we will just validate it again. I don't know why it's not clicking. It should in most of the cases. Okay, so normally we do the shape thing, but I don't know why this is not happening. But I hope you understand, we get a proper table and where we find out the records that have successful bookings, value greater than the capacity. So yeah, finally we have found that, and it's a very easy code to write, not too complicated at all. So I hope you learned something from this video. I will start with data transformation in the next video.